All right, everybody, we are going to start our chapter. So this is our first lesson. You want to write this down on a piece of paper, copy my notes as you are watching. Feel free to stop and pause if you have any questions, maybe go back and review the lesson and then write any question marks down or things like that that we can go over in class. So today we're doing lesson 7.5, solving exponential equations with common bases. So we're going to see some equations today that are going to have exponents in them. And our goal is to get these what's called common bases. So the first thing we're going to do is make sure we review these exponent rules because we are going to need them today. So anything raised to a negative power is means that it was a fraction. So like if I have 2 to the negative second power, it'd be 1 over 4 instead of just 4. Okay. And then this one, anything raised to the 0 power is always going to be 1. And so these ones, and this is just one we have to know and kind of remember because sometimes it'll come up and it's kind of like a special case scenario. All right, so today our goal is to, hopefully you will agree with me that B equals B, that they are the same, okay? So if we have the same bases, then we're still going to keep that equal sign there. Then that means if these two equal each other, then x equals y. Like these two exponents have to equal each other as well. Now, the only way we can say that they equal each other is if they have common bases. So our goal today is to get common bases. So like these bases, b and b, be the same number. And then we're going to be able to basically set our exponents equal to each other. Okay, so let's look at a very basic problem. So we're going to start here. I'm going to put it right here. So 2 to the x power equals 16. Okay, well, a couple things. One is I don't have an exponent right here, but I also don't have common bases. I need them to have the same base. So what I'm going to do is I'm going to try and find a different way to express 16. So I'm going to go and say, okay, well, this is a base of 2. Can I make this a base of 2? So 2 to what power equals 16? So if I leave this the same, I take out my calculator and I say, okay, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. Okay, I'm getting closer. 2 to the fourth power is 16. So if I do 2 to the fourth power, now I've got common bases. Okay, so in our steps over here, we're going to put steps. Step 1 is to make bases the same. Okay, so that's what we just did. Step 2, we're now going to set exponents equal to each other and solve. Okay, so going back to this understanding right here, if our bases are congruent, in order to keep them the same, our exponents have to be congruent as well. So we now can basically cancel out those 2's, the bases, and we say that x must equal 4 in order for those 2 sides to be congruent or equal. Okay, so let's look at a couple more problems. So if I have number 2, so that's it. We cancel out our bases and set our exponents equal to each other, and in this case, we didn't have to solve. They will get more difficult. Okay, so now let's say we have this. All right, so now this is going back and looking at, so it says 5 to the x power equals 1 over 125, okay? So the first thing I see is a fraction, and whenever I see a fraction, I refer to this exponent rule. Okay, if it was a fraction, then that means my exponent was negative. So let me think about this. How can I use what I already have here. I have a 5 here. So can I make this 1 over 125 to some power? So 5 raised to the third power, because I know it's not 2, is 125. Okay, but I want it to be a fraction. It needs to match that. It needs to represent that number. So instead of 3, I'm going to make it a negative 3. I can even check and I can say 5 raised to the -3 power, and that gives me that number. So these two represent each other, the same equation, they just look a little different now. Okay, got my common bases. So now I'm going to set equations equal to each other and solve. Set exponents, I should say. So my answer is -3. Okay, moving to the third one. So now let's go to 3 to the x power equals 1. Okay, well, we look at this and we go, I've got a base of 3 here. This is just 1. I can't change 1 to be a base of 3. So I have to go back up to this little rule right here that we need to kind of memorize. Anything to the 0 power equals 1. So in this case, because 3 to some power equals 1, our x must equal 0. Because anything to the 0 power equals 1. Okay? All right, let's move on. Start to get to some trickier ones. So now let's do 5 raised to the 2x minus 7 power. Oh, we're bumping it up now. Okay. So 5 raised to the 2x minus 7 power equals 125. Okay, so I've got a base of 5 here. So usually our bases are going to be like 2, 3, sometimes 4, 5. So very small numbers. So that's kind of your goal in trying to find the numbers. Okay, so 5 to the 2x minus 7 equals, let's try to get this one to 5. And we actually already did this one here. We made it negative because it's a fraction. This isn't a fraction, so I'm going to keep it positive. All right, so now, again, set exponents equal to each other and solve. So cancel these out. The bases go away. We already know that those are equal, so now we're going to make these equal. So I'm going to add 7. 2x equals 10. And when I divide by 2, I get x equals 5. Okay. All right. So here's the next one. 3 raised to the 2x plus 4 equals 27 raised to the 2x minus 4. Okay, so what I'd like you to try and do is try and stop the video now and see if you can try and do this on your own. I'm going to go through it in a second, so might as well check to see if you can figure it out. All right, so hopefully you've tried it. Now let's see if you got it right. So base of 3 raised to the 2x plus 4. I need to change this to a base of 3. 3 raised to the second power is 9. 3 raised to the third power. Now, watch what I'm doing here. You can put your parentheses there or there, but you have to keep in mind that that 3 is 3 raised to the third power times all of this. Okay, that's the big trick in this one. So let's see how you did. So we canceled out our bases. I canceled out my base. So on this side I have 2x plus 4. And on this side I have 3 times 2x minus 4. So I've got to do a little distributing and then just simply solving. So let's work through. 2x plus 4 equals 6x minus 12. I'm going to solve for x, so it's up to you which way you want to bring your x's. I'm going to bring them over this way because I don't want to have a negative. So if I do over here, I'm going to add 12. I get 16 equals 4x. When I divide by 4, I get x equals 4. All right, we got one last one. I saved the best for last. Get excited. All right, so here it is. 64 x minus 2 equals 1 over 256 raised to the x plus 12 power. Okay, so whoa, big numbers, all right? So you just start out and just try to figure out, well, what can I do? Something raised to some power, okay? So I'm looking at these numbers. They're both even. So I'm guessing maybe I can start with 2, maybe 3, maybe 4. I would say within that range. So I'm going to do 2. Let's see what happens with 2. So 2, I know it's not to the second power. I can start maybe to the fourth power. So I'm just going to make a list here so you can see what I'm doing. That's 16. 2 to the fifth power, 32. I'm getting there. Okay, if I go 2 to the sixth power, I think I'll get there. There we go. 2 to the sixth power equals 64. Now, the key is if I'm going to do that same base over here, I've got to look to see if 2 will work for that one. Okay, so I already know 2 to the sixth power, so let's start from 2 to the seventh power over here. 2 raised to the seventh is 128. We're getting closer. 2 raised to the eighth power is 256. Okay, bingo. We got our 2 numbers. Now, what we got to do is figure out, okay, so this is going to be 2 to the sixth, all of that raised to the x minus 2 power. Okay, and then this one, now I've got a fraction. So we've got to go back to remembering this rule right here, that if it's a fraction, if it's a negative, not a fraction, it is a fraction here. That means it came from a negative exponent. So if it's a fraction, that means it had a negative exponent. So instead of just putting 8 as my exponent, I'm going to do 2 to the negative 8 and raise it to the x plus 12 power. Okay, so now we've got our common, let's go here, we've got our common bases. So I'm going to cancel out the 2's, and I have a 6 parentheses x minus 2 on this side, and a negative 8 x plus 12 on this side. All right, so now because we set them equal to each other, we're going to distribute. 6x minus 12 equals negative 8x minus 96. Okay, so now I'm going to add 8. And since I'm bringing over my x's to this side, I'm going to add 12 as well. So I get 14x equals a negative 84. And when I divide by 14, I get x equals negative 6. Okay. Now, I will tell you there is another way I could have done this. I could have actually done a base of 4. So I did do it base of 4 as well, but I ended up getting the same answer as negative 6. So sometimes they might have, as long as you can get to the same base on both sides, it really doesn't matter what you choose to have your bases. So again, going back over our rules, make bases the same. And once you do that, you cross out your bases, say your exponents equal to each other, and solve. Okay, so do the best that you can on the problems that I have posted, and we will talk about them in class.